Hi guys, today we are going to see about real numbers. The numbers which can be plotted on the number line is known as real number. That is, so this is number line. What are all the number I can able to represent here? These numbers I will say it as real number. So I can able to represent 0, 1, 2 or minus 1, minus 2 or even minus 1.5, and similarly here I can able to represent 1 by 3. Whatever I can able to represent in the number line, even root 2 I can able to represent, that you have seen in the 9th class. So what are all the number I can able to represent in this number line is known as real number. Why it is named as real? So that is, these numbers only we are going to use it in the real world. So these numbers is the numbers which is used in the real world. Yeah, we have imaginary number. This imaginary number we are going to study in our class 11th. So don't need to worry about imaginary number now. Now we are going to study about only real number. Okay. So what is natural number? The number which starts with 1, 2, 3 and keep on going. This number system is call it as natural number. And then we added 0 to the natural number and then we say it as an real number, whole number. Then we started using negative numbers, and with negative numbers and whole numbers together we started saying it as an integer. Then rational number, the number which can be expressed in the form of p by q, where q should be not equal to 0 is known as real number, rational number. The number which cannot be expressed in the form of p by q is known as irrational number. So in last year you might be studied the example of irrational numbers are pi, that is, or we can say root over 5 or root over 2, whatever prime number what we are writing in the root numbers, that is we can say it as an irrational number. Okay. The first topic of your class 10th, which is Euclid division lemma. What Euclid division lemma says is, given two positive integer a and b, there exists a unique integer called q and r satisfying a is equal to bq plus r, where r is greater than or equal to 0 but less than b. Okay. So here what is a, b, q and r? Before that we want to know the division algorithm. You all guys, I know that you know that division algorithm. If I am dividing a 20 by 3, what will be my remainder? That is, we can write it as 16 and we can like this, right? Okay, so 20 can be expressed in the form of 6 into 3 plus 2. This is what division algorithm says. You might be studying this from 6th standard. And what is known in Euclid division lemma is, he spoke about this r. That is, my remainder value will be in the range of 0 or equal to 0 or more than 0, but always less than b. That is, always 1 less than b. That is, here I am dividing a number by 3. So my remainder value can go up to 0, 1 and 2, not more than this, since I am dividing by a number by 3. That is, if I divide by a number by 5, what will be my remainders? It can be a 0, 1, 2, 3 and 4. This says that if I dividing a number by a dividend, that divisor, the remainder cannot go above the divisor, or even a divisor cannot, we can't get it as a remainder. That's what Euclid division lemma says. Okay. So if I give two numbers, for example 36 and 15, represent in the form of Euclid division lemma. So how you will represent? You want to take largest number as a and smallest number as b. So here 36 is the largest number, so I am taking it as a, and 15 is the smallest number, so I am taking it as b. So then you want to do the normal division. 15. So 15 2s I can write it as 30. So what is my remainder? 6. So I can write 36 as, that is 15, that is my divisor. Dividend is equal to divisor into quotient. What is my quotient? Is 2. And what will be my remainder? 6. Right? So this Euclid division lemma speaks about this remainder. Okay. Anyway, this is the form of Euclid division lemma. That is, a is equal to bq plus r generally. So next important basic you want to know is HCF. If I generally ask what is HCF, you people will say highest common factor, and I know that you know to find HCF. But what is the general meaning of HCF. So before going to that, we need to know the meaning of factor and meaning of multiples. Okay, if I am given a number, let it be 30, and what are all the number which exactly divides the 30, that is without leaving any remainder, that is 0 as the remainder, how many numbers I can able to divide this numbers is known as factors. That is 1 will divide all the numbers, so which will give a remainder as 0 only. So 1 will be the factor for all the numbers. 2, if I am dividing a number 30 by 2, I will get the remainder 0, so 2 is also a factor. 3, when I am dividing it 30 by 3, I will get the remainder as 0, so 3 is also a factor. Then 5 is also a factor since remainder will be 0. 6 is the factor, 10 is the factor, 15 is the factor, then 30 itself a factor. So these numbers, when I am dividing a 30 by these numbers, it will give a remainder 0. So I will say these numbers as a factors. Okay. Then what is multiples? If I say 40, this number is the multiples of 2. That is, in 2 times I can get 40, right? So I can say it as a multiple. Okay. In other word, I can say that if I take 35 as the number, and what are all the multiples of this is 35, 70, 105. It means what are all the numbers which comes in this table, I will say that as multiples. So these are the multiples of 35. These are the multiples of 35. Okay. Now what HCF means is, HCF is highest common factor. It means if I am giving two numbers, let it be 35 and 15. So I know highest common factor means it should be a factor, right? So I am writing 35's factor separately and 15's factor separately. What will be the factors of 35? Anyway, 1 will be the factor for everything, and 5 will be there, 7 will be there, then 35 will. For 15, what will be the factors? 1 will be there, 3 will be there, 5 will be there, 15 will be there. Okay, these are the factors. Now, in this, for these two numbers, what are all the common factors are there? If you see, 1 will have a common factor for all any two numbers, and other than that, what are the other factors are here? 5. In this 1 and 5, which is largest or which is greatest? 5. So this is highest common factor. Highest common factor. So from the name we can able to conclude that factor means the number which divides completely. So here for two numbers, these are the numbers which divides these numbers completely, and it should be common for both. So that's why the common word come. So 35 and 15, what are all the common factors I have here? 1 and 5. 1 and 5 is repeated in this 35 and 15. So I am taking this thing, and since it is written highest, I am choosing the highest number which is dividing these two numbers exactly. That is highest common factor. Okay. So we give some numbers like 12 and 14. What will be the least? How you will find? So you know the prime factorization method already, right? So 2 can be represented in the form of 2 into 3, and 14 can be represented in the form of 2 into 7. So if I write, there will be 2 into 2 into 3 into 7. So 21 into, so it will be 84. So 84 is the number which comes in both 12 table and 14 table, and this is the least number. After that many numbers may come, but this is the least number which comes in 12th table and 14th table. So I am saying it as an LCM, that is least common multiple, that is least common multiple. Okay. So one of the application of equal lemma is to find the HCF. So now we are going to see about this division algorithm. So what division algorithm says, that already I taught you, that is if two number is given to me, that is 35 and 70, I want to choose which is the largest number, and that number I should take it as A. and the remaining number will automatically come as b. So I want to express these two numbers in the form of a is equal to bq plus r, where q and r are quotient and remainder. To find the quotient and remainder, I will divide this number by 35. So it will be 2s are 70, remainder 0. So how I can write? 70 is equal to 35 into 2 plus 0. So this is Euclid division algorithm. This is Euclid division algorithm. Using this Euclid division algorithm, we can able to find the HCF of two number. For example, if I am taking a number 320 and 140. What is the HCF of these two numbers? If I want to find this, what I can do is, first step what you have to do is, in these two numbers which is greater, I want to assign that number as A, and another number will automatically become B. So now I want to divide these two numbers, that is 320 divided by 140. So I can write as 2s are 280, and what will be remainder? 40. So I can express this in the form of A is equal to BQ plus R, that is A is 320 which is equal to 140 into 2 plus 40. Now I want to check my remainder, whether my remainder is 0? No. So if remainder is not 0, I want to continue the same step for my B, that is this is my B here and this is my R for next time. That is, now 140 is the smallest one, so I want to take 140 here and I want to divide this number by 40. So if I divide 140 by 40, I can write just 3s are 120, so remainder will be 20. So I can write like this. So 40 into 3 plus 20. Right. Now once again I am checking my remainder. Whether the remainder is 0, I can stop here and I can say my B as my LCM. Since B is not R is not equal to 0, I will take once again my B and R for the same step. That is 40 is equal to 20 into 2 plus 0. Right. Now what is the division here? B here, divisor, that is 20. Now 20 is the HCF. You guys understand this? That is, I will explain once again. If two numbers is given, as to find HCF, first take the largest number as B and largest number as A and smallest number as B, and try to express in the form of A is equal to BQ plus R. For that I will divide and I will get my quotient and I will get my remainder. So I will express my 320 is equal to 140 into 2 plus 40. So I will check my remainder. Remainder is not equal to 0. So I will continue the same step for my divisor and remainder. So my divisor is 140 here and my remainder is 40. So once again I will divide that. So I will get remainder as 0, not remainder as 0. So it is 20. And once again I will take my B and R and repeat the same thing until I am getting my remainder 0. Once I get the remainder is equal to 0, I will take at the time what is the divisor, that as an HCF. 45 and 60. If I take these two numbers to find the HCF, so what will be my A? Largest number is A, so 60 is A, and smallest number will be 45, so it is B. So now I will try to divide this number. So 45 ones are 45, so remainder will be 15. So I can express 60 is equal to 45 into 1 plus 15. Now I am checking my remainder. Remainder is not 0, so I will select my divisor and my remainder for the same step next time. That is Euclid division algorithm for next. So 45 is equal to 15 into 3. We can write like this, right? So my remainder became 0. So what is the divisor here? 15. So this 15 I will say it as HCF of 45 and 60. So I already told what is HCF, right? So the 15 is the largest number. 15 is the largest number which can divide both 45 and 60. Both 45 and 60. If you see very properly, if I write 45 and 60, there are many number of common factors. 5 can divide both, 1 can divide both, even 3 can divide both, but 15 is the largest number which will divide both the numbers. That's why it is called highest common factor. Okay, so this is very important sum, guys. So you want to understand what is Euclid division lemma. So Euclid division algorithm says how to find the HCF of two numbers using Euclid division algorithm. Okay, so one more example is given, that is 12,576 and 4,052. So first, what is the greatest number? So 12,576. So I will take this number as A and this number as B. So I will try to divide that. I will get like this, that is 4,052 into 3 plus 420. So now I will check my remainder. My remainder is not equal to 0. So I will continue the same step for my divisor and remainder, that is 1052 is equal to 420 into 9, and once again I find the remainder which is not equal to 0. I will continue this step up to my remainder became 0, and when the remainder is 0 I will see my divisor. This is the highest common factor for these two numbers. Okay, now the same sum I am going to repeat for 135 and 225. So which is higher? So this is higher, so I can take it as A and this is B. So 225 can be expressed as like this, right? So I will divide 225 into 135. So I can put only once because it will cross. So 225 can be expressed in the form of 135 into 1 plus 90. Now I will check my remainder. Remainder is not 0. So I will repeat the same step for my B and R. So divisor is equal to 135 is equal to 90 into 1 plus 45, right? That is, if I divide a number 135 by 90, I will say it as 1. So my remainder will be 45. Since now also it is not 45, so I will continue the same thing for 90 is equal to 45 into 2 plus 0. So now what is the number I got here? 45. So 45 is the HCF of these two numbers. Okay, so this method, so we can't say it as a shortcut, but in your one slot we have to do, I will show you another method. That is, if I am having a number like this, I am going to divide 225 by 135. I will put 1 here. So what will be my remainder here? So 135, I will get the 90 as the remainder. Now 90 is the remainder. What I will put here, I will continue the same thing. 90 is the divisor and I will put 135 here. Okay, so once again I can put 1 here. So if I put 90, my number will be 45. Since it is not 0, now I will divide this quotient. I will write here, that is 90. So 95 2s are, I can write it as 90. My remainder became 0. So when my remainder became 0, what is the number I divided? This number I can say it as HC. Okay. Okay, so this is very important sum, very important sum. So these kind of proving sums will come from Euclid division lemma. So what they told is, show that any positive odd integer is in the form of 4q plus 1 or 4q plus 3. That is, they told any number, all the numbers in the number system can be expressed in the form of A is equal to BQ plus R. So that is the one of the uniqueness of Euclid division lemma, that is any number. So if I take any number, so I can write like this, right? A is equal to 4q plus R is also the one of the form which I can express all the numbers. Whatever number in the number system, I can able to express in the form of 4q plus R. Okay, I will take this as a number. Why I took 4q plus R is, since I want to prove that it is 4q plus 1 or 4q plus 3, which is positive odd integer. So since this is the case, for whatever, since D is 4, what will be the cases of R? What are the numbers I can get as the remainder? Since the divisor is 4, I will get 0 as the remainder. I can get 1 as the remainder. I can get 2 as the remainder. Even 3 as the remainder, not more than that, right? Since my divisor is 4, I can have only 4 remainders, that is 0, 1, 2 and 3. Okay, so next what I will do, I will put case 1. what the case 1 is, my remainder is 0. What happens if my remainder is 0? If my remainder is 0, a will become only 4q, right? Okay. If it is 4q, I can able to express in the form of 2 into 2q, right? Any number, let n is equal to 2q. Any number which is the multiple of 2, then it will be a even number, right? Okay. Now case 2. What case 2 says is, when r is equal to 1, that is a is equal to 4q plus 1. Here I can't able to represent like this. So what I will do, I will represent only 2q, 2 into 2q plus 1. Let it be as n. Here it will be 2n plus 1. So whatever number which is 1 more than the multiple of any two numbers, then we will say it as odd number. This is the general format of odd number, you know, right? 2n plus 1, that is instead of n, whatever number I put, I will get only odd number. Now I will go to case 3. What case 3 says is, my r will be equal to 2, that is a will be equal to 4q plus 2. I can take commonly 2 outside, so 2q plus 1 will be out inside. I will take this as n, so 2n. So once again it is even. The case 4 is r is equal to 3, that is a is equal to 4q plus 3. Now 3 can be written as 4q plus 2 plus 1. We can write like this, right? So I am taking common this 2 from outside. So 2q plus 1 we will get. I will take this as n. So 2n plus 1 I will get. Now wherever we got the odd number, this is also odd, right? This is also odd. Wherever we got the odd number, if you say the a, it is 4q plus 1 or it is 4q plus 3. That is what they asked, right? Show that any positive odd integer is in the form of 4q plus 1 or 4q plus 3. See, this is how we want to prove this sum. So I will once again repeat this, guys. It is very important sum. Like this they will ask, the n number of sums are there. So what they asked is, we want to prove that any positive odd integer is in the form of 4q plus 1 or 4q plus 3. You want to know that all the numbers, whatever number in whatever integer, that can be able to expressed in the form of a is equal to bq plus r. So a is equal to bq plus r will become a general number, general form of a number. Since it is a general form of a number, I will take b as 4. So 4q plus r. Why I am taking this as, let this is I am taking. Okay, why I am taking as, I want to prove it as 4q plus 1. So by seeing the question itself, we can take this 4q plus r or 3q plus r, whatever we want, we can take according to the question what we want to prove. So here 4q plus 1 we want to prove, or 4q plus 3 we want to prove, so I am taking as 4q plus r. So according to the Euclid division lemma, we know that r will be in the range of 0 greater than or equal to 0, but definitely less than b. Here in the place of b we have 4, so the number should be greater than or equal to 0, but definitely less than 4. Since it is definitely less than 4, and this is the number which we will get, right? 0, 1, 2, 3, which will be in this category. So we are taking r as first, r is equal to 0, a is equal to 4q. Now this 4q can be expressed in the form of 2 into some number, that is, if any number which is in the multiple of 2, then it will be definitely even. And in the second case I am putting r is equal to 1. Here 2n plus 1 is the format what I got at last, so that will be the general format of odd number. So this is also an odd number. So once again I am repeating this for all 4, and what are all, when and all I got the odd numbers, I have a structure of a 4q plus 1 or 4q plus 3. So that's what this proving sum is. Okay. Similarly, here the same kind of sum, what they do, use the Euclid division lemma, show that the square of any positive integer is either in the form of 3m or 3m plus 1. Since here it is in the form of 3m or 3m plus 1, which I want to prove, I will take my a as 3q plus r. Okay, I am not taking it random, from what it is given I am going to take. If you take it as 3, it will be easy for you. So that's why we are taking like that. Now what we have to prove here? Square of any positive integer. Square of any positive integer is either in the form of 3m or 3m plus 1. Okay. So what will be my remainder? So according to the Euclid division lemma, what my r should be greater than or equal to 0, but definitely less than divisor. My divisor is 3 here. So what will be the numbers I can get? 0, 1 and 2. These are the 3 numbers I can get when dividing a number by 3. I will take a case 1. So case 1, I will take r is equal to 0. So since r is equal to 0, my a will become only 3q. So since they told square, I will take square of this number. So if I take the square of this number, what will be this thing? 9q square, right? If I write 9q square, I can write like 3 into 3q square. We can express 9q square as 3 into 3q square, and I can take 3q square as some m. Let it be. Let m can be 3q square. So I can express that 3 into 3q square into 3m, right? Okay, let it be here. I am going for case 2. What case 2 says will be r is equal to 1. I finished this, now I am going for this. So r is equal to 1. So a is equal to 3q plus 1. So next step what I have to do? 3q plus 1 the whole square. So you all remember a plus b the whole square formula, right? So what will be the answer here? 9q square plus 1. I'll write like this, 6q plus 1. That is 3q the whole square plus 2 into 3q into 1 plus 1 square. So at last I will get like this. Now I can be able to take 3 from this 2 number, right? I will take 3 from this 2 number common. What will be the remainder here? 3q square plus 2q plus 1. I will take this as m now. So what will be my case now? 3m plus. Okay. So what is the remaining case I have to take? R is equal to 2. That is a is equal to 3q plus 2. So once again I will take square. So what will be the answer here? 9q square plus 12q plus 1. Okay, that is a plus b the whole square format. Once again I am taking 3 as common here. Not 1, it will be 4. Now this 4 can be expressed as, I can write like this, right? There is no objection for that because 4 can be expressed as 3 plus 1. Nothing wrong in that. So I will take 3 as common now. So what will be there inside? 3q square plus 4q plus 1, outside plus 1. So this number I will take it as m. So my answer will be 3m plus 1. So square of any positive integer will be either 3m or 3m plus 1. So that's what this sum asked. So hence proved. Okay. So whatever number which can, all the number can be expressed in the form of a equal to 3q plus r. So I am taking it, and the Euclid division lemma says that the remainder will be of only these 3. So whatever number it will be in this either 3 cases. So I will get only this as a resultant. Okay. So another very important sum in the exercise 1.1 is a army contingent of 616 member is to march behind the army band of 32 member in a parade. You know, right, what is parade? So if you see a parade, how it will be? It will be of 2 groups. First group will have a musical team. So first musical team will go, that is military army band we will say. This music group will go first. After that followed by a military members. Okay, army people will go after this. Like this it will go. Now what are the cases? There are 616 members of army people who has to march behind the 32 members of the band. Okay, and two groups are marched in the same number of column. That is, I can have whatever number of rows, but they has to fill in the same number of column. So what is column, what is row? This is whatever I put is column and this is row. Okay, so I will say this as R1, that is row 1, row 2, row 3, and this is column 1, column 2, column 3, like this. Okay, so what they want is, what is the maximum number of column in which they can march? So they want to know the maximum number of column which they can march. At the same time, there should be no gap in between. So that are the general cases that you should consider. Okay, now I will take the sum here. See, there are 32 members and 616 members. I want to arrange in a way there should be no remainder. Okay, that is, no people should be left out. The easiest way of arranging is, I can arrange like this. That is, one behind one another, 32 members, and after that 616 members, one behind one another. Okay, so the row will be very long. That is, only one member can stand at a time, another member should stand behind him. Like this we can arrange. So what is the problem is, they asked maximum rows. They asked maximum row column what they can arrange. Okay, so let's go for 2. If I arrange in 2, what will happen? Military band members will become 16 and 16. They will form 2 rows. At the same time, here also 308, 308. We can form 2 rows, right? This kind people can go. Very good. Okay, why can't we try third method, that is 333? If I make to stand in 3, I will have a problem here because 32 is not divisible by 3. So in last row only 2 numbers will be there. From up to 10 rows only 3 people will be there. In 11th row only 2 people will be there. In one place will be remainder, that is not allowed in the military parade. So this will be not suitable. So 3 is not suitable. Where 1 is suitable, 2 is suitable, 3 is not suitable. Why? Because 1 and 2 are the common factors of these two numbers, where 3 is not the common factor. That's why we can't able to form in 3. Okay, now I can consider 4. If I consider 4, it is possible. Why? Because 4 is also the common factor of these two. If I consider 4, if I see, I can able to make it as 8, 8 4, 4, 4. So 8 band people will go. Okay, so like this I can make the military people. So at the same time, here 156, 156, 156, 156. This kind I can able to make. So 4 people are able to make. So by this I want to know the highest number common divisor which can divide these two numbers. So for that only we have a name called HCF, which gives the highest common factor of these two numbers. So I already told what is HCF, right? So this is how the application sums will be. So I want to know the highest common factor of these two numbers. For that, what the method I have? I have a method called Euclid division lemma. Okay, so what we have to do? We want to find the HCF of these two numbers, that is 616 and 32. So this will be my A and this will be my B. Why? Because this is the largest number. So I am dividing these two numbers, that is 616 by 32. I will put like this. Okay, 19, sir. Yeah. So I can write like this 6 not. So my remainder will be 8. So 616 can be expressed in the form of 32 into 19 plus 8. Now my remainder is not 0. So what I have to do? I want to continue the same step for my divisor and remainder. So 32 is equal to 32 8 into 4 plus 0, right? So I got the remainder 0. So what is my divisor here? 8. So 8 is the HCF of these two numbers. Okay, we find the HCF. Now we can go to once again to the sum. It means that I can able to make 8 persons in a row. First 4 will be my military band. Similarly remaining will be my 616 members. They also will stand in 8 per row. So this is what we can able to find. So 8 is the number in which my military band and military people has to stand for a parade. So this is the maximum number of columns that we can able to make, right? 1 2 3 like this. This is the maximum number of columns that you can able to make. So this all that I find the common, which is the highest common factor for these two numbers. Okay. So next very important theorem is fundamental theorem of arithmetic. What fundamental theorem of arithmetic says is every composite number can be expressed in the form of product of primes, and this factorization is unique apart from the order in which the prime factors occurs. There are importantly, we see there are two types of numbers, that is one is prime number, another one is composite number. So what is composite number and what is prime number? If I say a prime number, that prime number will not be divided by any other number other than that same number, right? And 1. So if I say 7, 7 is the one of the prime number. So in this prime number, it can divide by 1 or it can divide by 7. So this is the prime number. But composite number, let it be 14. This number can divide by many numbers, that is 1, 2, 7, 14. So the numbers which has more factors is known as composite number. Okay, so what this says is all the composite numbers, that is any number like 25, I can write in the form of product of their prime numbers, that is 25 can be written in the form of 5 into 5, right? Okay, so if I take 30 can be expressed in the form of 2 into 3 into 5, right? So this order may change for you and me. If I ask you to write 30, you will write as 5 into 3 into 2, okay? But all the composite numbers can be expressed in the product of prime numbers, and this will be unique, and other than this order changing is not a problem. But I have only 1 5 here, 1 3 here, 1 2 here. Here also I have only 1 5 3 and 2. So this is this fundamental theorem of arithmetic says. So what fundamental theorem of arithmetic says is all the composite number can be expressed as the product of prime numbers, okay, and that will be unique and other than the order in which they are expressed. So that what my fundamental theorem of arithmetic says. Okay, so using prime factorization, so after listening to the fundamental theorem of arithmetic, I can take a prime factorization of any number. What is prime factorization? From the word prime number, I want to use the prime number and I should divide this. Since fundamental theorem of arithmetic says that all the numbers will divide by any one of the prime number, right? So if I am taking a 140 as the number, if I continuously divide by a prime number, then it is known as prime factorization. So I can take 2, right? 2 is also a prime number. So I will take 2 and it will be 70. I will take 5. This will be 14. I will take 2 once again. This will be 7. 7 is also a prime. Yeah. So 140 can be expressed as 2 into 2 into 5 into 7, right? Or simply 2 to the power of 2 into 5 into 7. Okay, if you multiply this number, I will get 140. So this is known as prime factorization. So next thing is how to find the HCF and LCM if HCF is known. That is, this theorem says that if I am having a 2 number, let it be 36 and 12, we can able to find the HCF of 2 numbers, right? So what will be the HCF of 2 number here? Here HCF will be 12 itself. So HCF will be 12. And we can find the LCM. We need not to find by any other method. We have a formula called A into B, which is equal to HCF into LCM. I know the HCF, so I can able to find the LCM. That is, LCM is equal to then A into B divided by HCF. So what is the A here? 36. What is the B here? 12. And what is the HCF here? 12. So what is my LCM? 36. Okay, so it's more easiest way for finding LCM with if you know the HCF. Okay, if I take 45 and 60, and HCF of this number we already found in the video, so it will be 15, we know, right? So now I want to find the LCM of these two numbers. What I need not to do is, once again I need not to have a prime factorization find. I am having a formula called A into B is equal to HCF into LCM. So now I know the HCF, so I need only LCM. So LCM can be expressed as A into B by HCF, right? So what is A here? 45. What is B here? 60. And what will be my HCF? 5. So I can cut this. So my LCM value will be 180. So 180 is the LCM of 45 and 60. So this is where the easiest